Hello everyone. Today we have an exciting video actually. We have a AI model that I've trained for Edison formats. So it's something I wanted to do for a while. It's something I thought about for a while, like can it be done? Because again, training AI models and so similar things, it's what I do kind of every day. And then we have a Edison format, which I also play pretty competitively. So I'm trying to like bridge this gap and of course kind of marry the thing I know with the thing I like, even though I like both. And yeah, so see how that's gonna perform and just kind of like maybe expand the horizon of the community towards some ideas, right? Like maybe this would be something novel that people would be interesting to see and something I want to see, right? So I'm doing it as well for myself just to see what's going on here. Can we extract some information that could be valuable for the players, but for myself and some kind of secret text. Now, I doubt we will see some secret text, but all in all, in any case, it's fun to see, and it was a huge project, one that took actually several months, and even collecting the data, processing the data, managing it, training the models, them not performing so well, so then switching to some other models, then yeah, running some statistics. Well, that being said, actually, this will be a three-part series. So this is part one. This is where I show like what I've done initially, and then in the later parts, it's kind of improvement. So stay tuned for that. I'll be uploading the next video probably by next week, because it actually takes me a while to make these videos. So make sure to subscribe to support kind of my work, because yeah, I'm doing a lot of this work for kind of like for you and for myself. But then again, I mean, sometimes I ask myself, is it even worth, right? Because it's really a lot of work. Now, yeah, with that being said, let's get into it. So here we have the motivation. So why I did that, right? Like so this stems from Modern, where I was told in the Snake Eyes format, people said like, okay, you just see the opening hand and you know who won, right? And in Modern, this is pretty evident usually, like you know who wins based on the opening hand. But in Edison, this is starting to creep in, right? Like you can usually kind of guess very well who won based on the opening hand, right? If someone has like double whirlwind Shura and the other person's kind of having nothing of that much value, then you would probably say, okay, this person has won, especially at the high level of play. So if you were to have this opening hand, we would ultimately try to predict the outcome based on the game, right? And this would be pretty cool. I thought about money matches, right? Like technically, if this turns out to work well, you could place like odds on the money match just from the opening hand, so that like opening hands, so that way it's fair in a sense. Like you could say, okay, well, if you have like 80% chance of winning and you have like 20%, then like the odds should be 80-20, right? Now, again, I mean, I don't want to get into the whole money match part of it, but yeah, this would just be like one of the applications. Another way to see this, like another thing that motivates this project is like see how fake the format is. Like if it's like 80-20 for most matches, or like the model can predict 80% of the times the winner, then this means the format's pretty fake, right? Like you have this 20% to work with, and I mean, that doesn't sound like a lot. While on the other hand, if it's like 50-50, the model's really not that good, then that might mean that the format's actually pretty healthy, right? So it's not really easy to predict the winner from the opening hand. Yeah, justify the bitching, right? Like if you're like 90-10, like 90-10 in their favor, then you can, I guess, complain. But if it was like the opening hands were pretty equal and we cannot really actively predict anything from the opening hand, then that might mean that there's a lot more of like play involved, right? Like there's a lot more of action you could do to like win throughout the game. Now, sometimes that might not work, sometimes that might work, but just the opening hand, we can train a model and then see, okay, can the model really just say, okay, the opponent's going to win and you can't do nothing about it. And in that case, you can, I guess, complain and it's justified. Yeah. And then just to see like which cards in the opening hand are too strong. And can our model like reflect this? So can our statistics reflect this? Can we say, okay, like double whirlwind is like, I don't know, 80% chance of winning, but if you open like something else, then you have a lower percent chance. So I mean, there's many ways this project can go in, and many uses, but in the end, the motivation is usually this first one, like how much can we, like how fake it is in terms of opening hands, right? How much influence do they have? And yeah, with that being said, we could get into where we started. So of course we start with the data, 1 million replays. After some pre-processing, this comes down to like 800,000. This is the shape of the data set, of the data frame. And yeah, it's like this tabular data. So you could see it as like an Excel spreadsheet, for example. You could imagine it that way. And yeah, we have the first the hand of the first player. So player 1, card 1 through 6. So this guy's playing like Norleris, right? Phantom of Chaos, Norleris, Greffer, Trade-in, Foolish, Norleris. The other players playing Blackwing, so Mirror Force, MST, Dark Corruption, Heavy, Colute, Icarus. Then we have first player, meaning who went first. And then we have the winner column, right? So the person that went first and winner are like encoded in binary. It's like so 0 and 1. And 0 is the player 1. And 1 is player 2. So I just want to make sure this is understood because we will use it after. And yeah, so 0 means player 1 and 1 means player 2. And yeah, I've built this data set for some time now. So yeah, many people ask me how I get my data and stuff. I actually put a lot of effort into data sets, so I don't intend to share it. So yeah, if you intend to ask that, just don't, I guess. And yeah, it's a huge data set that I cannot even process on my local machine. So it takes me some days to access my cloud to do the processing. So it took many hours to actually get this data frame. So this kind of looks simple, but trust me, there was a lot of work just to have this data frame loaded up. Now, once we have the data, of course, the AI model doesn't really speak in terms of English, right? Like, doesn't really understand what a colute is. So we need to encode it in numbers, and we just take all the cards, we put them in like a big list, and then we just take the index and we encode it, right? That's just like label encoding. Yeah, so we pre-process it into these encodings and we can feed it into the model. Now, then after we have that, we should be able to train. And what do we actually train on, right? So we have these this data, these 17 columns, 14 columns, with 13 of them being what we train on, and then the 14th column being the winner is what we're trying to predict. So it's a simple classifier model, right? It classifies like 0 or 1 if the model expects the player 0 to win, and or like player 1, right? So 0, or player 1 to win, so means player 2. And ultimately we're trying to predict this winner column. So first we train, right? We give the model examples, so all 14. But then finally, when the model is trained, we just give him the 13, and he needs to predict the 14th value, which is actually the winner, right? So that's usually how this works. It's like supervised machine learning. So we give him, it's like with supervision. So we give them the labels, and the labels are the winner, right? The winner column. So we have that in our data set. And we use 80-10-10 train test validation split. This is not really that relevant. And the model we use is like a very traditional machine learning model. So it's not a neural network per se. It's actually just like a series of trees, and it's called XGBoost. So it's like, it stands for extreme gradient boost. So it's like a gradient boosting technique. That might be too much to understand, and you should not really care that much about it. I just want to say it. And yes, we have this XGBoost classifier that works very well on tabular data, right? So we have this tabular format. And it's designed to handle this basically, and it's very easy to run. Like you see, we can define a model with just a few lines of code. Yeah, with that being said, once we train the model, I will show you how we do inference. So how we run a certain like configurations to actually get the predictions. Now, yeah, I work a lot on this, as you might maybe notice, and it takes me a lot of time to just like do all of the things I've done. I show you, but also make the presentation, train all these models, and yeah. With that being said, if you really like what you see and if you find this interesting, make sure to subscribe. And also, there's a Patreon in the description. So if you want to support the channel, please do so. Yeah, I had to put this slide in because I always forget like to ask for subs and for Patreons. But yeah, if you want to do that, it's in the description, and if you don't have to. It's all good. Yeah. So here we have player 1, which has black whirlwinds and substitutes in their hand, for example, and then we have player 2, which has a bunch of blue eyes, right? So blue eyes would be a brick, and then whirlwinds and substitutes would be very strong. Even like this is not realistic. You cannot have 3 whirlwinds because it's semi-limited, and you cannot play 6 blue eyes. I mean, the model doesn't really care that much about this. It just kind of sees some cards and then associates kind of some power to them. At least that's what we suspect it might do. And then we transform these hands into the vectors that encode the number of the card. So as you can see from before, like values such as this, right? So as you can see, even for example, 3 whirlwinds, 3 substitutes, you can see these numbers are the same, so which means this is whirlwind, and then these numbers are the same, which means this is substitute, and then this is a bunch of blue eyes, so 294th card. So we just make these encodings, and then if we were to stick them on this one next to the other, that would be 12 values. And remember that we trained on the 13 values to predict the 14th, right? And the 13th value was this value was the first player. Which player went first, right? So this is the second player. Remember, 2 is second, 0 is 1. So this guy went first, then 0, this guy went first, and 0, this guy, and then this one. So we say that the first player 1 goes first, right, with the 0. So he basically opened cracked and he's going first, right? So as we can see, the probability is 0, which means the first player has won, which is what we suspected. And the probability of winning, or the confidence of the model, is 81%, and the confidence that the player 2 will win is 18%. So yeah, not very good for the player who's going second and has 6 blue eyes in the hand. But let's say maybe, okay, this fact that he's going first might influence a lot the decision. And if we put the second player to go first, maybe the model hasn't learned that much about the cards and is just kind of estimating based on who's going first. Well, let's then just change this number to 1, right? So same hands, but we're letting the player 2 go first. Well, the player 1 still wins, right? We're predicting 0, and with 65% win rate. So the win rate drops if you go second, obviously, it's very clear, but it's still a huge difference, 65 to 34, right? So we are learning about the cards in hand, and not only, for example, the who went first, right? So this would be very strong, but then this is also very strong. So we're not seeing a, for example, 50-50. However, this is unrealistic, so let's maybe get to a realistic example. So here we have a very strong Blackwing hand. So we have Shura, Whirlwind, Dad, Heavy Storm, Dust Shoot, Mirror Force. That's player 1, right? Here. Then we have player 2, kind of mid, right? Treeborn, Ocean, Dupe, MST, Dupe, Raigeki Break. Kind of very bad hand, especially compared to this. Now, again, we do the same thing, encode, and let the first player, so the Blackwing player, go first. 72 compared to 27. Very, very strong. The player 1 is winning, that's what we predict, and with the 72% accuracy, or 72% confidence rather. Now let's make the player 2 go first. Well, we can already see it's 54 to 45. So it kind of also makes sense if you were to say, okay, Whirlwind Shura, but then we have an MST, we have a Raigeki break to handle that. Set Dupe, set MST into this hand is not that bad. So yeah, Dust Shoot might be not so good going second. So we are learning some things, and the ways seem pretty yeah, I would say stable. Because we are, again, the Blackwing player is going second, and but he still has a better hand. So yeah, with that being said, this is kind of inference that we could do with this model, but I think we should get into the actual accuracies of the model and some numbers that the model predicts after it trains. So like running this inference could be cool, but it doesn't tell us about the general image of how the model is performing, right? We're just kind of testing for some random hands. So let's look into that. So these are the results. The model can predict the going first hand with 60% or 61%, actually, let's be exact, 61% accuracy. And yeah, this is very good. So this means that basically the format is fake 40%. But on the other hand, just going first is actually also 60% accuracy. So by looking at the hand, we are in a sense getting this 1% accuracy, but keep in mind that this might be a little bit misleading, because as we saw from the examples before, for example here, even though the Blackwing player is going second, because we have a 1 here for the second player, he is still predicted to win. So on average, you will have the same number of like correct predictions as basically going first, but our model can tell us a lot more about the opening hands and the start of the game than just who went first. So yeah, with that being said, we have the model here. This is the accuracy. You can see the scores if you're interested in this. But yes, it's kind of unfortunate that these numbers are very similar, and again, they don't really show the same thing, because again, going first is, as you can see from the code, it's just like the sum of the people who went first and won divided by everyone, right? Divided by all the games. So that comes out to 60%. I've talked about that in another video where I did the statistics of going first, and yes, game 1, if you go first, you're 60% basically guaranteed almost to win, 60%, and then you have to work for the other 40%. The model kind of reflects this, but it also, during inference time, we can work with different hands, and then depending on the hand, we can kind of, even if we went second, we still might have a higher chance of winning. So yeah. Now, yeah, these are not so good numbers. I would really like to push the model further to explain away this going first aspect, and try to add more complexity to the model so that it can generalize better to the hands. So we have a part 2 coming out where I'm trying to use more sophisticated models to push these numbers up. So I was not happy with 61%. Although I don't know how much further we can go. It's definitely something to explore more. But we did manage to push these numbers a little bit up, and I will explain some techniques on how to do that. So in part 2 in particular, we use deep learning, right? So we trained several deep learning models. And yes, to explain away this going first, right? We tried to generalize better. And we actually trained one model, not even on the going first part, so just on the hands, to see how the model can perform and how much can we extract just from the hands. Because going first is very important. It's like a data point we have at the start of the game. So if you're just looking at the game and you say, oh, I know who's going to win, you already know who's went first and the hands, right? It's kind of a context within which you make this statement. Now, yes, in the part 2, we are definitely going to try to expand this. But in general, yeah, that would be pretty much it. So I hope you enjoyed this part. There will be a part 3 as well. In this part, we will talk more about some statistics and certain cards which were kind of influencing certain decisions, and the ones that were actually pretty good to open, like you saw now, for example, Whirlwind and Sub, and the Blue Eyes was not that good, right? That's why we had this very, very strong prediction for player 1. And again, if you like what you saw, please subscribe, and yeah, check out the Patreon in the description to support the channel. And yeah, in any case, I will see you in the next video, and peace out.